Here's our essential question for this video. What is the difference between congruence and similarity? What is the difference between congruence and similarity? So congruence is something that you talked about last year in Integrated Math 1. And now we're going to be introducing this new idea or new transformation that creates similarity. All right, a little bit of a review. Congruent means same shape, same size. And our math symbol looks like an equal sign with a little tilde or a squiggly on top of that. Get used to that symbol. You'll be seeing that a lot. Similarity or similar means same shape, different size. So the shape is the same, but the size has changed. It could be smaller, could be bigger, but the size is changing. It's not changing the shape, however. The math symbol for that is just the little squiggly. It's kind of like the top of the congruence symbol, just the squiggly line. And then there's something we have to understand when we start talking about similarity, and really with congruence as well, and that is corresponding parts. Corresponding parts are sides or angles that are in the same position. Corresponding parts can sometimes be hard to figure out when shapes are reflected or rotated. If you look at our example right here, these two triangles haven't been rotated or reflected. They're the same orientation, so it's pretty easy to figure out that this side right here corresponds to this side right here. And just as with the same thinking, you could say, okay, this angle right here must correspond to this angle right here. But I can tell you, when you start reflecting and rotating shapes, it can be a little more difficult to figure out what is the corresponding side of the two shapes, or what is the corresponding angle. I'll teach you some tricks or some abilities to be able to figure out what the corresponding sides or angles are. So just keep in mind, this is our word we need to understand, is a corresponding part. And let's see how that applies to this next part. So again, a little bit of review here. Are these triangles congruent? So let's take a look at them. Let's go ahead and label the vertices. Let's say this is A, and this is B, and this is C. And let's call this vertex D. Remember, a vertex is where the two sides of a polygon come together and touch each other. This is E, and this is F. So here's how we can prove these triangles are congruent. If corresponding angles are congruent or equal, so we can say, all right, if we know that angle A is congruent to angle D, angle B is congruent to angle E, and angle, let's put a comma there, and angle C is congruent to angle F. Whoops, forgot to write the angle. To angle F. So here we are saying that, all right, we know that all of the corresponding angles are congruent. And if we know the corresponding sides are congruent, so our corresponding sides, let's write that out. Corresponding sides would be, okay, so we'd match up AB. Side AB is equal to, let's go ahead and say line segment AB is congruent to segment DE. And then segment BC is congruent to segment EF. And then segment I'll just call it AC, is congruent to segment DF. So now look what we've done. We've said, okay, if all the angles have a corresponding angle which is congruent, and all the sides have a corresponding side that is congruent, then we know that triangle ABC is congruent to triangle DEF. So there's our basic understanding of congruence. Okay, let's take a look at similarity now. Now similarity has a little different twist to it, because if you remember from the definition, similar shapes, similar objects have the same shape but different size. Take a look at these two triangles. They appear to be the same shape, but one of them is smaller than the other. Let's go ahead and label those vertices again. We'll call this one A, B, and C. a little better. And we'll call this one D, E, F. So we've got triangle ABC and triangle DEF. Now take a look at our proof of two things being similar, or two triangles at least. If corresponding angles are congruent or equal, so the same thing applies to our congruent triangles. We need congruent angles, or congruent corresponding angles. So again, we've got angle A is congruent to angle D, angle B is congruent to angle E. If I can make that E look readable, to angle E, and angle C is congruent to angle F. If all three of those corresponding angles are congruent. And here's the twist, and the corresponding sides are proportional. By proportional we mean they've grown by the same ratio. They've grown by the same ratio, or in this case we could say they have the same scale factor. Here's how we can write that mathematically. If corresponding sides have the same proportion of the same scale factor, that means if we take corresponding sides and make ratios out of them, so notice over here we've got AB is congruent to DE. Here we're going to say if the fraction AB over DE is equal to the fraction BC over EF, and that's also equal to the fraction of AC over DF. Now notice what I did. I just took all the corresponding sides and I made them into ratios. If every one of these ratios is the exact same value, that means we have the same scale factor. If we have the same scale factor, that means that this triangle shrunk from this triangle by the same proportion or the same ratio on every side. So it's the same shape and just a different size. And if we can say this is true, and if we know all the corresponding angles are congruent, then we know that triangle ABC is similar to triangle DEF. So there's a basic rundown of how we talked about congruence last year, and now this year we're adding something else. We're adding the possibility of two shapes, in this case two triangles, being the same shape, but they're different sizes. Instead of with congruence, they were the exact same size.